And now we move on for the next case, that is trigonometric function, right? So f of x is equal to maybe sine of x or sine a of x or cos of x or cos a of x, right? So for this case we have yp of x equal to 1 upon p of d sine a of x, or yp of x equal to 1 upon p of d cos of ax, right? So this will be applied on cos of ax, this will be applied on sine of ax, right? So in this case we need to replace d by minus of a squared, right? So previously we replaced d by alpha, which was the coefficient of the exponential, right? uh, in the exponential function, and in this case we are replacing d by d square by minus a square, right? So remember, here we are replacing d square by minus of a square, not the d. Okay, so because of this, when we replace d cube, so this will become minus a square d, right? You multiply this equation with d, you will get this. So again you multiply this equation with d, you will get d to the power 4 equal to a to the power 4. So in this fashion we need to replace all the d in the polynomial, right? So the answer we will get here is sine of ax divided by p of d square equal to minus of a square, if p of this function is not equal to 0. So here it should be p of d square equal to minus a square is not equal to 0, right? So p of d not equal to 0 at the point at evaluated it on this point, right? So now what we will do, if this becomes 0, we will put x 0 sorry, x in the numerator and then p dash in the denominator, right? So here it should be a p dash, right? And again, if this and for the for this the condition is what, it should be 0, that is p of d should be 0, and p dash should not be 0. But if this becomes 0, then what we will do, we again go to the next power of x and then next differential of p, right? So this goes on until we get the last differential not equal to 0, right? And the uh, remaining previous differentials equal to 0, right? So these are the formulas. Now we will see some examples to explore this. So for this case, the first example we have is d cube plus 4d y is equals to sine square x, right? So this polynomial is applied on y and we will get sine square x. So the yp of x will be what, 1 upon d cube plus 4d sine square x. For this case we need to first convert this sine square x into a trigonometric function. This is a square of the trigonometric function, that is sine square x. So for this case we need to replace this by a general 1 degree trigonometric function, right? So we know that cos of 2x is equals to sin cos square x minus sine square x, right? So and that cos square x we can write it as 1 minus sine square x. So the sine 2 square x, sine square x will become what, 1 minus cos 2x divided by 2, right? So sin square x we have written it as 1 minus cos 2x divided by 2. Now we will apply this 1 upon p of d onto this function, right? So the function we will get for this first part of this f of x, we will need to replace d by 0, and for this second case we need to replace d by minus of 4, d square by minus of 4, right? So what we will get here is p of 0 is 0 and p of d square equal to minus of 2 square is also equal to 0. So now we need to go for the first part, right? That is the first differentials of them. So we will get here what, this one equal to e to the power 0x, and this we will apply on this function. So now when yp of x is equals to what, x into this e to the power 0, that is 1, divided by 2 p dash 0 minus x into cos 2 of x divided by 2 into p dash d square minus 4. So how we arrived upon this is, we have done because we are getting 0 in the denominator, we have taken the first differential and put it an x in the numerator, and we have taken the first differential for this as well, and we have put it x in the numerator. Alright, so now you can see the p dash of d will be equal to what? 3d square plus 4. Now you put 0 in this case, you will get 4, and now you put d square equal to minus 4 in this case, you will get minus 8. Right, so the answer we will get here is x into 1 divided by 2 into 4, and x into cos 2 of x divided by 2 into minus 12 plus 4, so that will be minus 8. So answer we will get is x by 8 plus x cos x, or x into cos 2 cos of 2x divided by 16. So this is the answer for this example. So this is how you need to be careful whether the denominator is becoming 0 or not, and if it is becoming 0, then you need to take the differential, and you need to take the d square equal to minus of a square, and for this case you can easily see that this is one can be written as e to the power 0 of x, right? So this one can be written as e to the power 0 of x, and then we need to replace this d by 0. So this is how it goes, and you need to practice these types of problems. Now for this we will take one more example for this case, and the example is as follows. Alright, so for this case the polynomial function is this, and the f of x is the same for the as in the previous case, that is sin square x, and we can replace this by 1 minus cos of 2x divided by 2, right? So yp of x for this case will be what? Yp of x will be 1 upon p of d applied on f of x, and for this we replace this by 1 minus cos of 2x divided by 2 into p of d, right? So p of d is d cube minus d square minus d minus 4, right? So for the first part we will replace d by 0, and for the second part we will replace d by minus 4, d square by minus 4, and d cube by minus 4d, right? So we will take 1 upon 2 p of 0, right, because of this 2, and minus 1 upon 2 p d square minus d square will be equal to what? Minus 2 square, so cos of 2x. So when we replace this, we will get 1 upon 2 into minus 4 minus cos of 2x divided by 2 into, now you replace this d cube can be written as d into d square, so the other part, that is d square, you will replace it by minus 4, then this d square minus of d square will be replaced by what? Minus 2 square into minus, so this will become plus 4, and minus of d you again have as it is, and this minus 4 as it is, so this minus 4 and this minus 4 will get cancelled, right? This minus 4 minus 4d and minus d will become what? Minus 5 of d. So the answer you will get for this case is what? Yp of x equal to minus 1 upon 8 plus cos of 2x divided by 10 of d. Now this 1 upon d will be applied on this function cos of 2x, right? So 1 upon d can be written as the first integral, right? Right. So the integral, and 1 upon d square I have told you is equals to what? Double integral. 1 upon d cube is what? Triple integral. So this is how the formula comes into play, right? So the answer we will get here minus 1 upon 8 plus 1 upon 10 integration cos of 2x dx, right? So remember and be careful how we have used that formula, that is 1 upon d into the consideration, right? So this will become integration cos of 2x dx. Now this cos of 2x dx integration will become what? Sine of 2x divided by 2. The answer we will get is sine of 2x divided by 2, and the whole answer will become what? Minus 1 by 8 plus sine of 2x divided by 20. Alright, so this is how these questions are to be solved, right? And you need to be careful how you are applying these equations. Alright. Okay, so these are the first two cases we have seen for particular integral, and we have seen how to find the complementary function by using the auxiliary equation or the roots for this case, and the nature of their case of their roots, right? So there were four cases possible. for the complementary function, right? So there were 4 cases possible for the complementary function, and for particular integral we have just in 2 cases now. Now in the next lecture we will see the other remaining 4 examples, right? So this is all guys for this lecture, and see you in the next lecture.